Chapter 20 is on expected value. So, if you are thinking about spending money on a lottery ticket, you care about your chances of winning, but you also care about how much you can expect to win. That value, how much you can expect to win, is an example of an expected value. This is what we'll be studying in this section of notes. So we're going to start with an example to illustrate what expected value is. Suppose a sorority is selling 1,000 raffle tickets for $1 each. One ticket is going to be drawn at random and the winner is going to get $200. There are two possible outcomes here. You win the $200 or you don't win the $200. So if we look at expected winnings, there are two outcomes. You could win the $200 or you could win $0, right? If we talk about how much you gain, if we're computing expected gain instead of expected winnings, the net gain, if you were the one to get drawn to receive the $200 prize, is $199 because you get the $200 but you already spent $1. So you've only gained $199. And if you don't win, your net gain is negative. It's minus $1. So let's just think for a minute how we would find the average gain for this game. So let's talk about the sample average that we've already learned. We're going to think about average gain. And how do we compute an average? We took all of our observations in a data set, added them up, and divided by the number of observations. Here, we're going to consider all the outcomes. So we have, for gain, we either have win $199 or lose your dollar. So we've got one person that's going to win $199. And then we've got the first person who loses their dollar, plus the second person that loses their dollar, all the way up to the last person that loses their dollar. And how many minus ones are there? How many people lose their dollar? Only one winner out of the 1,000, so 999 lose their dollar. And how many total possible outcomes are there that we just added up? There's 1,000 of them. 999 who lose their dollar and the one person who gains the $199. So that's the way we've always computed average before. And I would like you to practice punching that in on your calculator. But I've punched it in on mine, and it comes up to be minus 80 cents. Now, why did we get a negative number for our average gain? Because if the sorority is going to make money off this raffle, then your expected gain needs to be negative, and thus their expected gain needs to be positive. So we were expecting it to be a negative average gain. Now, to motivate what we're doing, we're going to rewrite our calculation. So I am going to put another equal sign right here, and I want to regroup this calculation. So if you recall, when you're dealing with fractions, when you have one thing in the denominator and some stuff added in the numerator, you can split those up into separate fractions. So I'm going to take the 199 over 1,000 and write that by itself. And then I'm going to put all the negative ones over 1,000 in a separate fraction. Okay, so when you have a single number in your denominator, it's okay to break up the numerator into separate fractions. And then I'm going to write it one more step. And again, the top line was our answer, but we're just rewriting this to illustrate a point in just a moment. I hope that you remember, but if not, we're going to remind you, 199 over 1,000 can be written as 199 times 1 over 1,000. That means the same thing as 199 over 1,000. And I'm going to rewrite my 999 negative ones over 1,000 as the number negative 1 times 999 over 1,000. Now that you should have learned from your high school math, but if you've forgotten, it's okay. Just remind yourself now. I won't ask you to do anything like that on an exam in this class, but I hope that you can keep up with us when we're demonstrating these kind of calculations in the lecture notes. So if you believe that that math is okay, what do we have here? We've rewritten our first calculation, which we all understood was just an average, add up all the outcomes, divide by the number of outcomes, as a weighted average of our possible outcomes. This is outcome 1 for gain, win $199. This is outcome 2, lose your dollar. And then they're weighted by their probabilities. 1 out of 1,000 people is going to gain the $199, and the other 999 of 1,000 is going to lose their dollar. When we write it this way, the definition that your book gives of expected value should make a bit more sense. The expected value of a random phenomenon that has numerical outcomes is found by multiplying each outcome by its probability and then adding all the products. In symbols, if the outcomes are A1, A2, A3 through AK, we'll be dealing with money a lot in our examples in this class, so you can think of that as amount 1, amount 2 through amount K. And their probabilities are P1, P2, P3 through PK. That would be their probabilities. So P1 is the probability of gaining amount 1, P2 is the probability of gaining amount 2, etc. Then the expected value is going to be A1 times P1 plus A2 times P2, etc., etc. Notation. We're going to call this capital E with the square brackets the expected value operator. We're going to read E square bracket gain as expected gain. An expected value is an average of all the possible outcomes. Now we're going to do our sorority fundraiser example again to find the expected gain, but we're going to notice the use of the definition of expected value this time. So we're going to show you way 1 to compute an expected value, which accentuates the definition that we've learned in the book. So this is by the definition that we've learned. And then we're going to do way 2 at the bottom, so kind of leave some space down there. So way 1, if you follow that definition that was given, you can write an outcome probability table. Where you're going to put your outcomes on the top and your probabilities that correspond to them on the bottom. So how much can we gain in this sorority fundraiser? Well, we've already talked about it. We can gain $199 with 1 out of 1,000 probability, or we can lose our dollar with 999 out of 1,000 probability. Notice that my probabilities add to 1. If we're exhausting all the possible outcomes, all the probabilities should add up to 1. And when you write your outcome probability table in such a fashion, then you can just follow the definition to compute your expected gain. Then you literally take outcome 1 times its probability, so 199 times 1 over 1,000, plus outcome 2 times its probability, until you go all the way through the table. Now we are all the way through this table because we only had 2 possible outcomes. So we're done after writing these 2 things to add. And again, if you punch that in your calculator correctly, you should come up with minus 80 cents. Okay, now that's one way to do it, and here's way 2. Now some people prefer way 2. It makes more sense to them. Some people prefer way 1 because they're creatures of habit and they like following the little steps and having an algorithm and getting the right answer. A lot of students do both ways, and then they have some measure of comfort that they haven't made any calculation error. If both answers match, then they feel a little bit better that they've got the correct answer. So way 2 is to take your amount that you could win times its probability added together then subtract the amount you spent on the game. Subtract the amount spent. So how would that look in this example? Then my expected gain would be, remember it's the amount of the winnings times the probability. So the first amount you can win is 200, and the probability of winning that is 1 out of 1,000. The second amount you can win is 0, but 0 times its probability is always going to give you 0, so you don't need to worry about the not win situation when you're computing this using way 2. So the only amount you can win is 200. It happens with probability 1 over 1,000, so we have nothing else to add to that because that's our only amount that we can win. And then we subtract the amount that we spent. And if you punch that in your calculator, again, it comes out to be minus 80 cents. So I hope having the two methods will help you to have some measure of comfort that you can compute the correct answer when computing expected value. Now, if I just asked you to compute the expected winnings instead of expected gain, then it would just be the 200 times 1 over 1,000.